Are you ready to explore exciting careers in neuroscience and neurotechnologies? Then join me, your podcast host, Dr. Milena Krastenskaya, or simply Dr. K, and my amazing guests on the Neurocareers Doing the Impossible podcast. Discover what it takes to turn the impossible into reality. Tune in now to a thrilling episode number 37. Dear Neurocareers podcast listeners, welcome to another exciting adventure into careers in neuroscience and neurotechnologies. Our today's guide on this journey is Eva Esteban, an award-winning embedded software engineer at OpenBCI and a true trailblazer in the world of brain-computer interface technology. Eva has significantly contributed to Galea, a cutting-edge headset that integrates brain-computer interface technology with mixed reality. Her expertise in wearable sensing and autonomous systems, paired with her background in neurology research and virtual medical reality, make her a highly skilled professional in the field. But Eva's achievements don't stop there. She is also the founder of UniPeers, a nonprofit dedicated to supporting international students pursuing STEM degrees in the US. With her passion for pushing the boundaries of neurotechnology and inspiring the next generation of engineers, Eva is truly a force to be reckoned with. So, sit back, relax, and prepare to be inspired by Eva's journey and groundbreaking work. Join us on another episode of Neurocareers, where we explore the people and neurotechnologies that make the impossible possible. Thank you, Eva, for joining us today. And can you please introduce yourself and let us know where you are joining us from and something interesting about the company you are working at?
Thank you for the introduction, Milena. Thank you for having me as well. I'm really excited for this conversation. Right now, I'm in Brooklyn, New York. I'm actually in the OpenBCI office. Right before I spoke to you, I was writing some code for Galea that's going to be running in the next version.
Okay, thank you. And can you tell to those who are maybe not very familiar with OpenBCI, although I highly doubt it, I think everybody in the field knows about it, but if somebody new is joining the field, what does OpenBCI do? And also Galea, what product is that?
Yes, so OpenBCI is an open source neurotechnology company. Our mission is to make these technologies affordable and accessible all over the world, so that people with different backgrounds can get started with the technology and apply it in their field of expertise. The latest product that we've been working on is called Galea, which I guess would be the interesting thing that I would mention in the first question. Galea is a headset that integrates different biosensors with mixed reality technology. So it's the first headset that integrates all these different data types, which comprise brain data, facial muscle data, eye data, so for eye tracking and pupil data, for example, heart rate data, and also electrical activity around the eyes and skin conductivity. We've basically integrated all those data types into a mixed reality headset, the one that Vario makes, the XR3, and also into a virtual reality headset, the Aero headset by Vario as well. And we provide you with this hardware platform plus a software package that includes different applications that you can use to visualize the data in real time and also to integrate the data into the software that you might be using for your experiments or for your game development, like Unity or Unreal Engine.
Thank you so much. And what are those possible applications of Galea? Maybe you can give some examples of people or different labs and how they are using this technology.
Yeah, so Galea has a wide range of applications. We at OpenBCI, we call ourselves technology enablers. Basically, we focus on building the hardware and the software, and then we hand it to people in different industries. With Galea, we found that some of the main industries that are interested in this product are the entertainment space. So a lot of companies, for example, Valve, the gaming company which we collaborated with in the past, are using this equipment to be able to figure out how to adapt gaming experiences to players, and using the information of motions, for example, the game is producing on the player, they can come up with experiences that will keep you engaged or match you to players that might be a good fit for your level. Another industry that it's been really popular in is the training and simulation industry. So a lot of companies that are developing flight simulators or car simulators to train pilots, for example, they need a way to quantify whether these pilots are learning efficiently, and they also need a way to train them without spending so much money on physical equipment. So a plane is really expensive. And with a VR system, you can put the person into a simulated experience and measure, their stress level, their focus, what they're paying attention to, stuff like that, and figure out if they're learning efficiently and adapt the experience to them as they go. And it will also be way cheaper than an actual airplane. Another industry where Galea has also been received well is the healthcare space, obviously, especially for neurological condition research. Galea provides a way to put someone into an experiment and follow along using objective parameters. So, for example, if someone has PTSD and they're receiving PTSD exposure therapy, you can put them into a simulated scenario that will make them stress or trigger some of their symptoms. And at the same time, you can use the sensors in Galea to measure if they're getting stressed, if they're getting triggered, if they need to, leave the scene. So the experiment, the researcher running the experiment on the other side has access to all this data in real time and can adapt the experience depending on it, and can also draw conclusions of whether the person over time is responding better to the experience or worse, and you might need to adjust the treatment. There's other industries as well. So Galea is very, it's pretty applicable to a lot of things, but some of the most interesting ones that I've seen have been those three: entertainment, training and simulation, healthcare, like what I mentioned, PTSD or other mental health conditions, or even to research if you could diagnose certain conditions in a non-invasive way before, the symptoms pop up, because now you have a way to objectively measure some of the body information that the patient would not be able to relate to you. Because, whenever you're trying to analyze how something is affecting someone, you always have that subjectivity layer where you're asking them questions, but you don't know how objective their answers are because there's no guideline. If you tell someone, tell me your pain from 1 to 10, they may say 5 and someone else may say 6, and maybe their scale in their head is different and the person in 6 actually has more pain. So we're trying to figure out a way to measure this and remove the subjective layer so that researchers can draw conclusions easier and more reliably.
What is unique about Galea? How is it different from other VR or mixed virtual reality headsets?
I think Galea has a few differentiating factors that make it stand out from other similar devices. First of all, I haven't seen any headsets that integrate so many different data types into a single device. So, like I mentioned, we have the brain data, facial activity, eye tracking data, skin conductivity, even hard for me to remember all the different data types. And we have the heart data as well. And so having all these different data types allow us to calculate the metrics by using them to complement one another. So for example, if your eyes are closed, the image-based eye tracking is not going to be detecting where you're moving your eyes to or how fast your gaze is. And actually, how fast your gaze is one of the metrics that you can use to derive stress. But if you're relying only on image-based eye tracking, you won't be able to get this metric when the person has their eyes closed. So in Galea, we've incorporated EOG, which is electroculography, and that gives you information about where you're moving your eyes by using the activity that gets generated by the eyes on the skin, surrounding them. So if you're using Galea, you would still be able to check what is the gaze velocity of the person, even though their eyes are closed. And there's a lot of different examples of this where you might be looking at EEG data, and with only that data, you're not able to get a reliable metric. But then if you add the heart data and the skin conductivity data, it becomes much more easy to train machine learning models that are able to recognize that state. And I have seen other devices in the market that have integrations between EEG sensors and a VR headset, but I haven't seen any that integrate this wide range of sensors into a single headset. All the sensors are dry as well, so the setup is very fast. You just put it on and you run an impedance test. You adjust it a little bit, maybe sometimes you don't even need to, and then you're ready to go. So the fast setup also makes it stand out because a lot of labs have headsets that use gel or some conductive solution that'll make the electrodes connect properly through the hair. But we've developed our own electrodes in-house, and they go through different types of hair with no problem. It's very easy to set up. I use it all the time, and I have pretty long hair. And then I think another differentiating factor is the fact that we've integrated with the Vario headsets. Vario headsets are the highest fidelity ones available in the market right now. We integrate with both the Aero model, which is a VR headset, and the XR3 model, which is the mixed reality version of the headset. So a lot of the labs that we've spoken to, and also a lot of the companies that I see at conferences, are using Vario to provide the most realistic experience possible. And I think when you combine this wide range of sensors with the ability to provide very realistic scenarios, more realistic than other headsets could provide, then it becomes a very powerful product that can be used reliably by researchers and companies and people that are doing very important work where they need it to be accurate. So I think those are a few points, but I've been looking at the market to keep an eye on the different products that are coming out, and I still haven't seen that many sensors. And even when we speak to people, sometimes they highlight points about Galea that we haven't realized that make it good for their purposes.
Yes, absolutely. It looks like it's a really very unique product. Where does the name Galea come from?
It's quite a long story, actually. So I'll try to summarize it, but I think it's a beautiful story. It was mostly Connor's idea, our CEO. So Galea it kind of has double meaning. On the one hand, it stands for helmet in Latin. And, it is a sort of like a helmet. It looks a lot like the helmets that they used to use back in the day, if you go on Google and you search up for them. But most importantly, it's in honor of Gal, who is an individual that Connor met in the past, and who Connor, I think, worked with OpenBCI equipment when they were starting up the company, and Gal had ALS. So Connor always tells the story. I mean, he can tell it way better than me, but he went to this event with the Ultra Cortex, and a lot of people were looking at it thinking, what is that? That's so weird, and maybe not paying a lot of attention. And Gal was there, and he immediately recognized the potential of that technology for people like him to help him communicate more efficiently and maybe do tasks that he couldn't do at the time. And so Connor and Gal stayed in contact for a long time, and they were working on a system to help him with OpenBCI equipment. Unfortunately, he passed away a few years ago. So one of the applications of Galea is in the assistive technology space. And the name is in honor of Gal because he was one of the pioneers who understood the impact that this technology can have. And actually, assistive technology is another huge space that, is relevant to the healthcare environment that I was mentioning in the previous question.
Yeah, that's a beautiful story behind it. Thank you so much for telling about that. And this is connecting me to my next question, which was about the history of the company and also your input into the company, into the development of OpenBCI. How did it all start? How did you come to this company, and what are you doing right now?
So I joined OpenBCI around 3 years ago. I think it was 2020, after I graduated my master's here in New York. And the company had been around since 2014, I think, or 2013, when they launched their first Kickstarter. So the origins of OpenBCI were on Kickstarter. They launched as a low-cost platform to start making neuroscience more accessible. And then the Kickstarter was very successful, and they started building some of the core products. And then I think they did a second Kickstarter and started growing from there. So OpenBCI initially appealed to hacky people and makers that wanted to get started with this technology at home, maybe, or in schools. And then it slowly started to get picked up by research labs who started validating it against the systems that they were using in the research and saying, hey, I can get the same quality with OpenBCI as I can with this system, but OpenBCI is 1/3 of the price. So over the years, it became an industry standard. And then big companies started using it to prototype with, or even in their own products. So we have a long list of companies that have used OpenBCI. I think that's sort of how it grew. And then for the past 3 years or so, we've been focusing on Galea, which is merging this technology with mixed reality, virtual reality, augmented reality to be able to close the loop. So you're tracking the person's state, but you're also influencing it by using these technologies that give you audiovisual input. And so I came in at the point where Galea was still getting prototyped. So I remember my few first weeks at OpenBCI, I was actually working with the boards, but I was mounting them on cardboard and trying to wire everything up on my head. And I have a few funny pictures about that. So it's incredible to see now how we've put a device out there that is getting used in labs, actively used right now by alpha partners for the research. And we're, about to, in a few months, be shipping the beta version of the device. So it's been a very fulfilling journey to see it come to life. And right now I'm focused on embedded software, but to be honest, my role is hard to describe because even though my title is embedded software, we're still a small company. So I do wear many hats. In fact, Connor usually calls me the Swiss Army knife because I end up getting involved in everything. So my main responsibility is developing firmware. Maybe I do that like 60% of my time or 70. But I also do work on the communications, partnership, customer side of things. I do customer support. I take a lot of sales calls. I go to events, and I also recruit, and then I manage the interns. So I have a whole, range of different tasks that I always end up getting involved in, and I really like it. I think I thrive in an environment like that.
Yeah, so, what's your favorite part of your job?
For me, a very important part of my job is being in direct contact with the customers and seeing the impact that I'm having on their lives. So before I worked at OpenBCI, I was working as an intern in General Electric in their healthcare branch. Maybe I should backtrack a little bit to like how I ended up there, but I'm from Spain. I moved to the UK to do my undergrad. I did electrical and computer engineering at the University of Surrey. And when I was there, I did a 1-year internship with GE to finance, the rest of my studies. So it was like 1 year before I graduated. And even though I really liked my internship, the company is huge. So I was just working in this research department, and I didn't really know how my products were impacting people outside the company. I was doing a lot of research on Alzheimer's disease and also developing VR applications for doctors, for surgeons on how to perform, surgeries. Sometimes I found myself not getting enough motivation because I didn't know if what I was doing was going to be that helpful in the end or where it was going. So one of the aspects that I like about OpenBCI and one of the reasons that I ended up joining a startup is that I get to speak to the customers maybe like on a weekly basis. And I see the work that we're doing with our products and the papers that are coming out and the experiences that they're developing. And so I feel confident that I'm having a real world impact, especially on those days where I'm, spend the whole day solving a bug. And I'm in this state of like, oh my God, how do I figure this out? I'm so tired. Then I think about that and I'm like, okay, if I get this feature out, I know it's going to help such and such, and they're going to make an impact on, these people's lives. And so motivates me.
Yeah. And I think it's so important that in your work you are in constant contact with your customers, which provide feedback, and you are also so flexible and so attentive that you are responding to the feedback and you are implementing the features that people need to do the work that they want to do done. That speaks a lot about the work and your work and the work of your company.
Yeah, we actually have a interesting policy at OpenBCI where everyone has to do customer support. So the whole team does customer support, and that gives you a very good insight into what customers need, because a lot of times the engineering team can be disconnected from that, maybe building features that they think are cool, but no one's going to use. So by doing this, it really makes us aware of the pain points, and we all bring it back to the engineering meetings, and we prioritize based on what we're, hearing when we're doing the customer support. So I really like that structure, and I haven't seen it in any other companies.
Yeah, it is very unique. And what do you think wouldn't be possible if you wouldn't have this type of structure in your company?
I think if we didn't have this structure, then the engineering team might sometimes get disconnected from the real world applications of this technology, unless, some people are feeding in their requirements. But I think because we're all like OpenBCI is very engineering heavy. Most of the employees are engineers, and we have a background in pure engineering like me. Like I did electrical and computer engineering, and I have some background learning about the neuro side of things, but mostly I'm focused on engineering. And so I get excited by the latest tech and the latest features. And there's a lot of things that we feel passionate about building, but then we realize, the customers is not what they want. And maybe sometimes there's been instances where there's a very simple feature that we think, why would we add this? Like, no one's going to get confused by this. Like, who would click this? And then we get so many messages from people that are clicking that, and they're like, hey, I'm getting an error with this. And so we're like, okay, maybe it's worth adding. So I think the disconnect would be bigger. And also, I think for me, I'm someone that wouldn't enjoy just coding, like 8 hours just coding. That's not really my style. I like doing different things. So the variety keeps me entertained. I don't get bored.
Yeah, yeah, that's beautiful approach. You just mentioned that you have this background in electrical and computer engineering. Can you tell more how did you come to this field? How even you made the decision to become an electrical and computer engineer? Maybe you can remember yourself when you were growing up. Was it something that corresponds to your current profession of being electrical and computer engineer and working with the neurotechnology, actually?
I've had a pretty long path until I chose what I really wanted, even though I did choose engineering from the beginning, until the point where I figured out, okay, neurotech is a space that I like. It's taken me a while, and I've had to try different things. But if I look back to my childhood self, I mean, I think when I was super, super young, I actually wanted to be a Formula One pilot, which never happened. And I don't think I have the skills for that. So I'm glad, that I didn't take that route. But growing up, I was very lucky because I had my dad as an example. He's an engineer. My dad and I are the only people in the whole family that went into the science space. And so growing up, I always watched him fix the things that broke around the house, or the things that broke for anyone in the family. They would just come to my dad and be like, hey, can you fix it? And to me, it was like magic because he would fix anything. And so ever since I remember, I always asked for toys that were like robots or remote controlled things. And I opened them up and I tried to combine them to build something better. My parents didn't get a lot of things for me when I was growing up because they were expensive. So I always wanted some of the bigger toys. Like, for example, I remember I wanted this car where little kids can go and it looks like a real car, but they never got it for me. So what I would do is try to open a bunch of toys and combine their motors and see if it was strong enough to pull from like my bike and things like that. So I always was very hacky and trying to tear things apart. When I was growing up, also a funny story is that my dad, I remember his computer broke and he opened it up and this piece, it was like a metal piece, weirdly shaped, has broken. And he was like, oh no, I'm going to have to get a replacement. This is so expensive. And he was going online and he found they no longer make it anymore. I'm going to have to get a new computer. And I was like maybe 10 years old. And I remember I grabbed a few paper clips and I was soldering them or trying to combine them with glue as well. And I built a structure that was the same as the piece that had broken. And I was like, can you try this? And my dad was like, sure, like, let me humor her. And it worked. And the computer has been working until today. It's been like maybe 15 years. So at that point, I felt like, oh, I can also do magic like my dad. Like I can fix things. And I think it was like a natural progression from there into engineering for me. Also because physics, math, they were always my favorite subjects at school. So I ended up choosing electrical and computer because the subjects that they taught were the most aligned with my likings and also was very similar to what my dad had taught me. I did face, it was pretty difficult to make the choice because I did get picked on a lot as a kid because I was very nerdy and, you know, a lot of the kids were picking on me because I liked math and I liked robots. And they were like, if you go into engineering, you're never going to have a boyfriend, or like they would tell me all these things. So I had a moment of doubt there, but eventually I went into it and I'm glad that I did. And then I did my bachelor's, like I said, in the UK. And then, you know, the things that I wanted to work on were more getting developed in the US. And how I found this out was because when I was at GE, I already realized that I liked healthcare. That was sort of like an interest because some of the people in my family suffer from neurological conditions. And so I wanted to do some research to see if I could help them. And when I applied for an internship, actually at GE, they ended up giving me one, I think in the capital division or the finance division. And I remember my parents were like, yeah, you need to take it. This is GE. Like, take it. And I remember I was like, this is not really what I want. So I emailed them and I said, I want to be in healthcare. And they were like, well, in that case, you have to withdraw your application and apply again as if nothing had happened. Like, there's no guarantee. And I actually did it. I withdrew and I applied to the healthcare branch and I got in. My parents were like, you're crazy, but okay. And so I ended up getting in. And it was when I was there that I was working on neurology that they sent me to a conference here in the US to present my research. So I was actually the first intern ever that they sent abroad. I had to do a case for why they needed to send me. And this was mostly thanks to my manager who kept pushing me, being like, if you don't ask for something, you'll never get it. And I think, your research has been accepted to a few conferences, so I think you should go. So I ended up proposing and they accepted it and they sent me here. It was the Alzheimer's Association International Conference in Chicago that year. And when I was at that conference, I was reading some posters on EEG analysis to diagnose Alzheimer's disease earlier. Alzheimer's disease is one of, the neurological condition that's more motivating for me to investigate because my grandma suffers from it and other people that I know. So I was looking at that and I was thinking, what is EEG? And I think that's the point where I learned about BCIs. I started getting more into it. And when I went back to the UK, I did my thesis the last year in biosensors. So I developed a sensor to track the different wavelengths that people are exposed to during the day and to see how those impacted their sleep. So my sensors are being used by the sleep center at the Surrey Research. I think it's called the Surrey Sleep Research Center, close to my university. So anyways, I did my thesis and I started getting more into biotech, but I decided to move to the US because I didn't find that many opportunities in BCIs there. So I applied to Cornell Tech. Also, another decision that I took like pretty last minute. I didn't really tell my parents and I needed a scholarship. So I applied, I got accepted. I ended up getting a scholarship and I was like, guess what? Like I'm accepted. So I think I'm moving to New York. And my friends were like, okay, you're crazy, but we support you. And I came here and in Cornell Tech, no one in my class really knew about BCIs much. So I started working on projects by myself. I didn't really have any classes based on that. There was one class that gave us the opportunity to do our own thing. And so I proposed a BCI project for that. And I remember the professor told me, no one has ever done a project in this area. So I don't know if I'm going to be able to help you, but you can do it. And I ended up doing it with two of my classmates. We built a prototype for a wheelchair, like a little wheel that would turn around with concentration for someone paralyzed. And I think that was my segue into the field because I posted that project online. OpenBCI saw the post. And then, from there, it's history. I ended up interviewing with them and I did my internship. And that's the story of how I ended up in neuro. But a funny thing is that when I was back in Spain before moving to the UK, I remember some of my friends were actually using Ultra Cortex, the OpenBCI headset. I was a member of a few electronics association, like IEEE student branch and some of those. And I have this memory of them using this headset to build a detection for bruxism. So when you like clench your teeth at night. And I remember telling them, what is that? Like, you look crazy right now wearing that. And I didn't really understand what they were doing. And then years later, I'm here. And I remember I messaged that friend when I joined OpenBCI and I was like, guess what? I'm using the headset that you were using. So it took me a while to find out about this tech. And also, all throughout my degree, I learned about psychology in my own time. It's a topic that I've always been interested in, mental health. So I've done a few mental health courses, like, for example, mental health first aid for the workplace in case there's an emergency. And I remember I started reading psychology books from an early age in general. Like, when no one in my class was interested in that, I was reading some philosophy, articles. And I remember my friends were like, you're a little bit weird, but okay. And so I always had this mismatch of, I like learning about the brain, but I'm doing tech. And when I found this field, to me, it felt like it's the perfect intersection where I can combine my work and my hobby. And OpenBCI is, for me, the perfect company because of multiple reasons, some of the ones that I talked about earlier. So that's a little bit the story. Long answer.
Yeah, that's a beautiful story. And what do you think is like number one skill without which you wouldn't end up working at OpenBCI and working on brain-computer interfaces?
I think if I had to pick one, probably it would revolve around being able to wear many hats and do different things for OpenBCI in particular, but I think for the neurotech space, because it's still a small space, a lot of the companies are mid-size or small size. And in these companies, you're going to need to jump into whatever needs to get done to keep the business going in a lot of cases. So I think the ability to learn things fast and be adaptable, be open to learning new things and learn to iterate when things go wrong is very important, especially with emerging technology. You need to be able to be okay with failure. Like, there's a lot of things that you're going to try that are not going to work, and that's still progress because at least you're finding out the things that don't work. And this is something that took a while for me to learn because I'm a bit of a perfectionist. So growing up, whenever I made mistakes, I struggled, and I was, like a very good student and all of that. And in Spain also, it's a different culture to the US. I think in the US, there's this mentality of fail fast because it's going to help you. But in Spain, a lot of the times, obviously, this is a generalization. Not everyone is like this, but failure is frowned upon. And if you try to do something risky, a lot of people say, well, of course you failed because why would you even try? It's ridiculous. Whereas here, it's like people applaud you for trying, even if you didn't do it well. And that's a mental shift that I had to do maybe a couple of years ago that I think is also important for this industry because it's so new. No one knows where the limits are. So you need to be able to be okay with trying things that are not going to work. Otherwise, you're not going to take the risks necessary to build these things that no one really can imagine because it's so new.
Yeah, and what helped you to make this mental shift into be okay with failure?
I think a few things helped me to make the mental shift. I would say also I'm still in the process because, I it, sometimes I do shy away from opportunities because I think, that I'm going to fail. But in general, I try to force myself to do it. I think what helped me the most is kind of tricking my future self into doing it. And this is something that I apply both at work and in my personal life with things like sport. So, for example, if there's a race that I want to do and I don't think I can do it, I'll sign up first. Like, the race will be in, like, I don't know, a year. I'll do the sign up and I'll pay. And then I know that I have to do it. And then just the fact that I have that deadline is going to force me to figure it out. And I'm going to end up most likely succeeding at it, or at least learning something from it. And I think that kind of mentality is hard because in the moment you really don't want to do it. Or for example, if you struggle with public speaking, which is another thing for me, I used to be super shy, and now I'm here recording a podcast and doing talks. Usually, what I do with those things is I'll say yes and I'll put it in the calendar and I'll think, okay, I'm gonna worry about this later. And then when the day comes, I have to do it because I already committed. So I try to apply that mentality to a lot of things. And some of the things that have helped me the most in my career have come from that, including, for example, reaching out to people that I don't know. When I moved to New York, I didn't know a single soul here in tech space, nothing. And so what I started doing is reaching out to people on LinkedIn to interview them. And I think I got about 25% success rate from cold calls, which is very high in my opinion. And I ended up interviewing like maybe 50 engineers to see what their jobs were like and what I wanted to do after graduating. But for me, taking the step was very hard because I would get very nervous before the calls. I would think like, why am I talking to this person? They're a CTO. Why would they want to talk to me? I'm not going to teach them anything. And then you find that people are way more likely to reply to you than you think, but you have to push yourself through the initial doubt and avoid closing the door on yourself. Just let the world or others close the door for you. Don't do it before you even try, because a lot of times you're going to make it, even though you thought at the beginning that you couldn't. So embracing that mentality, I think, has been the most helpful, but it's come from, reading different books and also going to therapy and also, getting advice from people that are successful, that are kind of embrace it. So it's been a mix of things, but I would say that's the key point that I try to do on a day-to-day basis.
Yeah, thank you so much for sharing that. And many of the things you just mentioned, our podcast guests mentioned as well. For example, reaching out to people and to CEOs of companies and other professionals, because very often we don't think that they will reply, but actually they do. Yes, and this is also your personal experience. That's beautiful. And I think it's a good encouragement for our listeners as well. Many of our listeners are asking about the transition to neurospace when you are coming from the field of engineering or computer science, and you made that transition. What was the most challenging part of that transition for you, and how did you overcome it?
It's hard to know what exactly has made the most impact in my transition, but I think the hardest thing for me was getting over the initial feeling of I don't know what I'm doing, because I'm working on neuroscience and building tools for neuroscientists, but right now I don't even know what the different parts of the brain are. So I took some steps to mitigate that. For example, I took a course in brain imaging before I joined OpenBCI, that taught me kind of like the basics of the structure of the brain and different modalities. Also, my experience at GE helped when I was doing neuroscience research. I learned some of that, but when I was doing that research, I was very, very focused on a singular part of the brain. So I didn't really explore much outside of it. But I would say taking a basic course helps to at least, when you're in meetings, you understand what they're talking about. And then speaking to the people in the company that are handling the science side of things, or even to people in other companies that are working more on the clinical side, helped me a lot. So I would reach out to people in other neurotech companies and ask them questions about the main challenges that they're dealing with at their job, or ask them for recommendations on books or papers to read to kind of build a foundation on the basics of neuroscience. You don't want to go too deep, because at the end of the day, really, I'm building the tech, so I need to be focused on the tech, but I need to understand what the tech is going to be used for. And I think reaching out to the people in the company or other companies that are doing that is a great way. But mostly understanding that a lot of the companies need the engineering talent, and that you will be able to succeed even if you don't have the other background, because at the end of the day, the challenges that you're solving are engineering based. Like right now, today, I was working on the Wi-Fi for Galea. So everything that I'm dealing with right now is based on Wi-Fi and the protocols and the chips. So even though it's going to be getting used by researchers for the brain, the challenges that I need to fix are related to the data rates and the memory on the device and all these things. I think, for example, when Neuralink does announcements, they really put an emphasis on the fact that even if you're not from a neurotech background, you should apply if you come from an engineering background. I think a lot of people automatically, like I said, they close the door because they think they're not going to accept me, but you just need to get over the initial feeling that you're not the right fit by realizing that you are actually the right fit to solve the problems that you're going to be focused on, and then the rest is going to come as long as you make an effort to learn about the rest of the field. But you shouldn't close the door on yourself.
Yes, absolutely. And especially because right now the usual structure of the companies, it's very multifunctional. So people are coming from various disciplines, and there are scientists and there are neuroscientists that you can consult if you have questions. And of course, you can take courses. Like you said, you are working on engineering program, on computer science program. And if you need something to know about the application, it's not such a difficult knowledge to acquire. Yes.
Yeah, at least the basics that you need. Obviously, I'm not going to be able to interpret the data like the scientists in the team are, but I can learn the basics to know if the data looks good, like if it's clean, if the person, if they have high alpha, if they don't have high alpha, and some of the things like that that I need to calibrate the equipment. And also, especially, I think it's important to keep an open mind, be willing to learn things that are outside your job role. I think that's very important for smaller companies. Don't reject tasks just because they're not in your domain. Say, okay, I'm going to give it a try. And then if there's parts of this that I don't know how to do, I'll ask the person that I know has the knowledge to help me. But I think going through that process helps you to start gaining a more system level view of things rather than be pigeonholed in the things that you're solving, and then feel like you are part of the industry, and you have knowledge on the industry as a whole, not just the specific code that you're working on.
Yeah, absolutely. And in addition to the work that you are doing specifically at OpenBCI and related to directly to engineering and software development, you also do a lot of support work. And I know you did in the past as well. You are supporting people as a mentor. Can you tell about that part of your life?
Yeah, that's a pretty big part of my life, mentoring in STEM in particular, especially females, but I do, also male students. I started volunteering for STEM organizations in my first year of my undergrad, I think, if I remember correctly. And so back in the day, I joined the Women's Engineering Society as a committee member, and I was in charge of partnerships. So I would reach out to companies to basically try to organize events with them, or try to get them to give us donations so that we could host workshops and teach high school students about the basics of electrical and computer engineering and get them more interested, in the hopes that, we will increase the number of women joining these fields, for example. And so when I was at Sari, I was doing that. And then I think it really spiked up for me when I joined GE, because they had a program where you could get certified as a STEM ambassador. So I went through the course, and that basically gave me the background that I needed to start setting up events and workshops or giving talks. So me and the lead software engineer at GE, his name is Fifi, we used to host these workshops to teach high school students the cycle of app development, or principles like Scrum and Agile. And it would basically be like 2-hour classes where the school comes and we teach them, and at the end they end up building like a simple app or something like that. And it was very rewarding for me, because I never had that as a kid. Like I mentioned, a lot of people told me not to get into engineering. It wasn't really seen as a cool thing. And when we did these workshops, a lot of the students came in with the mentality of this is going to be so boring. And by the end of it, we had helped them to realize that engineering has so many different aspects, and you are not necessarily going to need to be like coding if you don't like it. You can also do design, or you can be the one like helping to debug or designing the whole system and how the components interact with one another. So by the end of it, a lot of the kids actually said, "Oh, this is pretty cool. Like I might consider it." So it gave me a lot of satisfaction, and we started taking that one level further and joined this organization called Girls Get Set, where we would take virtual reality systems to schools and put people in these experiences so that they could learn about new technologies. Back in the day, VR wasn't that popular. So most of these kids had never seen it before and their mind was blown. And for me, this was like a calibration because sometimes I had hard days where I couldn't figure out a problem. And then I remember these events and how they were so mind blown. And I would think, actually, I'm lucky to be working with this tech. And I'm grateful that these are the problems that I'm having. They're good problems to have. So it was like, in one sense, giving back to the community gave me satisfaction. In another sense, it was like a selfish interest in just getting calibrated back to reality of, okay, the work that I'm doing is cool, and keep using that as motivation. And I started running these workshops. And then when I went back to Surrey, I took some of the ideas with me and I started setting up sessions there. These were more mentoring talks. So at that point, I started getting my LinkedIn built up. And so people would reach out to me with, questions about, in that case, tech in healthcare. And I would just help them with, the knowledge that I had at the time. And when I moved to the US, obviously I couldn't continue doing those things because the organizations were in the UK. So I looked for some new opportunities. And two of the main things that I've been involved in is one, Unipeers, which is a nonprofit community that I created with Katie Donahoe. She's one of my classmates from Cornell. When we graduated, we created Unipeers, and it's basically a community to help international students come to the US to study a graduate program in STEM. The motivation for this was mostly the problems that I had back in the day when I was applying to the UK and then to the US to figure out how the educational system works. It's different in every country, and it's very easy to feel like you're never going to make it there. So I had a lot of these moments, and I didn't really have anyone to help. So I wanted to build a platform that can connect you to ambassadors at the university of your choice. And then those people will be able to guide you and at least show you what it's like to be a student there so that you can make an informed decision. Both of the universities that I studied at, I never visited in the past. I applied online, and then once I was a student and I committed, I went there to the campus for the first time. So I didn't know what to expect. I had never been there before. And it can be pretty daunting to leave your family, like everything, your family, friends, partner, everyone behind, to go to a place that you've never been in before. So I wanted to mitigate a lot of the risk to make it more accessible for students. So that's taking, a large percentage of my free time. But also I'm a mentor with the Knowledge Society that started recently. They basically they have, I think it's 13 to 17-year-old students who are building projects in areas of emerging technology. And to me, it's mind blowing because when I was 13, I didn't even know what I wanted to do. So I didn't start coding until my undergrad, pretty much. By then I was 19 or something. So seeing these young kids, installing Python and doing Python, I'm actually following OpenBCI tutorials that I've put on our website is crazy to me. I enjoy it a lot. They bring such a fresh perspective. And so what I do with them is both technical guidance, but also career guidance. So I have basically office hours that any student can book with me. And I think maybe like a couple of weeks ago, for example, I had a call with one of the students and she was trying to figure out a bug with her Python installation to try to get a tutorial with with an EEG headset working. Basically, I installed it in my computer. I figured out what the problem was, and then I helped her to get through it. That's one of the type of stuff that I do. But then I also had a kid with another student who was asking me, hey, I don't really know what I want to do for my undergrad. Can you tell me what neurotech is like? Can you give me some advice? Can you give me some resources? And I gave her some resources, like, for example, the course that the BCI guys have put out, which I think is really good for people looking to get into the space, and told her my journey and answered her questions. So I mentor them in those ways. And then on top of that, I also am part of a mentoring program at Cornell. So I'm both a mentor and a mentee. So I have people that I get advice from, and then I also have people that I mentor in the engineering industry in general, because I find that it's also nice to do things a little bit outside of neurotech for a change. So this program is more focused on just like ECE in general, electrical and computer. And my mentors have had a big impact over the years in my career. So I always try to give back and help people that are, a few steps, where I was maybe a few years ago.
Thank you so much. And you are doing absolutely amazing work, really mentoring and helping so many students to progress. And I think also to change a perception on tech, on technology, on engineering. Like you said, when you were at school, people kind of looked a little bit negatively at a woman becoming an engineer. Do you see any changes in perception? And what do you think helps to change those perceptions?
Yes, I definitely see changes in the perceptions. I'm pretty big from the conversations that I've had with these students. Now tech is cool. A lot of schools have added classes on how to code. Like, these students are coming out of high school knowing the basics of programming, which back in the day was not a thing at all. I didn't have any computer classes at my school. I think maybe I had one, and it was just us playing computer games. So it was mostly like a relaxation session. And these students are reaching out to speak to people who work in the space because they're excited for their future in it and proud to be working with this tech and show the people, show the world what they're building. I'm subscribed to a few blogs that the students have, and every month I get an update on what they've been working on, and they really put it out there as something to be proud of. Whereas back in the day, I was hiding my work in, tech, robotics. I didn't want anyone to know because it was not perceived as cool. And so I was always a little bit ashamed of it, which right now, even voicing it for me makes me realize how wrong it is, because tech is such an important part of society, and engineers, I think, build, some of the most impressive inventions that have been out there and that help us in our everyday life, like the computer and the microphones that we're using and everything. So I think being an engineer is something to be very proud of. It's also a hard path. Like, undergrad is hard, master's is hard. So I'm very proud of it. But back in the day, I used to be pretty ashamed. So speaking to these students and seeing them publish things, for me, makes me realize that there has been a shift in mentality. And I think one of the main reasons for that is having had role models. So seeing people out there, especially women, giving talks about their experience and being transparent about the obstacles that they have faced, I think makes this younger generations realize that it's normal to, like, feel at the beginning like maybe this is not for you. Or a lot of them will say, I'm not good at math, so I'm not going to do engineering. And engineering is not just about math. You don't have to be great at it. Anyone can code. Coding is based on logic. So I think it's something that you shouldn't be scared of. You should always be open to trying. And I think one of the main forces behind the shift has been people coming out there and being transparent about their challenges and showing that even if you feel like at the beginning you couldn't do it, you did it and you're there. So that's why I try to be transparent about my experience as well, because I think in the past, if my past self had heard someone, say this and say, hey, I wasn't sure, but then I ended up going for it. And now I'm super happy at the company that I'm working on and I'm making podcasts about engineering. Then I would have been like, okay, I'm not alone. I can do this. So definitely there's been a change. And also, I think organizations like Girls Who Code and communities that connect you to people that are on your same level and that may be facing the same challenges also helps. Back in the day, I didn't really have, internet had started, like social media had just started. So I didn't really have a lot of connection to the world outside of Spain, for example. And I think right now it's different with all the communities that exist and the social media platforms. You can get connected to someone, on the other side of the world that may be facing the similar issues to you. And it's always comforting to figure it out together.
Thank you so much, and thank you for doing all this beautiful work. And can you tell about your future plans? What are your next steps that you're planning in the future?
That's a great question. I'm still figuring it out, but I usually plan maybe like my next 3 years. And then what happens after that, I'll figure it out in another year. But I think for the next couple of years, my plan is to focus on building my tech skills still, because I'm still pretty early in my engineering career path. And I enjoy looking at systems as a whole. So I enjoy systems engineering a lot. And at OpenBCI, I'm starting to take charge of, smaller initiatives and projects, or do things like what I was mentioning, managing the interns. So my plan is to continue learning embedded software and at the same time start figuring out how to integrate systems together and how to lead bigger projects and bigger teams. I think the people aspect of things really resonates with me. So I see myself as someone that I would like to manage, big engineering teams at some point in the future. So I'm going to continue working on that path. And then on the personal side of things, I'll keep putting time into uni peers because I want to grow the community. Right now, we're going through a little bit of a revamp, taking feedback from people because we want to change the structure a little bit based on how the past, year worked. And then as also a big percentage of my time is going towards sports. So I've been getting more and more into endurance races, and I'm training for one in June. And then my plan after that is to sign up for another one that at that moment will seem impossible, but by signing up, I'll force myself to do it. So that's another area that I'm noticing a lot of benefit from, because a lot of the things that I learned in training, especially mentally, I apply at work. How to be persistent and how to push beyond what you think are your limits, which are not really your limits. So I'm gonna keep pushing on that side of things, and then apply that to my work and take a global view of things and start building bigger projects.
Yes, and you mentioned doing the impossible or what seems to be impossible. Maybe you can recall something that seemed absolutely impossible for you at some point in your life, but actually you made it possible. So, how did you make it possible, and what would be your advice of making the impossible possible?
I think there's been a few instances in my life where I felt like I wouldn't make it. Probably the most impossible thing that I've worked on is what we're working on right now, which I can't talk about 100%, but I can do a sneak peek. So with Galea, which is already a device that to me wouldn't have seemed possible a few years ago, I think Galea is pretty impressive. We are working on a application of Galea for a TED talk that Connor is giving in like 3 weeks. So I'm gonna be flying now with him and some other people of the team to Vancouver in Canada, where he's gonna be giving the talk. And the talk is gonna feature a demo. We're working on this demo with an individual called Christian Bayerlein. He is one of the earliest Kickstarter backers of OpenBCI, and he suffers from motor disabilities. So we are building an adaptation of Galea with which he will do a demo at this TED Talk, which I think is going to be very impressive. I'm not going to spoil what it is, but you'll know. We're going to be releasing footage afterwards. We're filming how the team is building the stuff. The theme of the conference is actually possibility. So how to make what seems impossible possible. I think our demo is going to be a great example of that. The fact that I'm working on this right now blows my mind. And I think it's going to have a huge impact on Christian, who's always wanted to do this. Big supporter of OpenBCI and BCI space. So that one example. I think in my personal, from a personal side of things also, moving abroad, even though from the outside it might look easy, like you catch a plane and then, you're in this new place already. For me, it was pretty challenging because I left everything behind, not once, but twice. And when I was thinking of going abroad, I thought it was impossible. Like I really didn't know how to start working towards it. And just the moment when you're landing in that new place and you're all by yourself and you need to figure it out and it's not your first language, can feel pretty daunting. And there was a lot of times where I wanted to go home at the beginning. Now, of course, I'm acclimated. But back in the day, it was one of the things that has made me prove to myself that I can do hard things and I can figure it out. And also, when I was trying to move out, a lot of people told me, "You're crazy. Like, why? Like, just do your studies here and stay with your family and be, like everyone else." But I wanted something different, and just believing in myself that I could do it, I think, was an important step for me. And in terms of how to make the impossible possible, I think this is very related to a book that I'm reading right now. It's by David Goggins. He's amazing. He has two books, Can't Hurt Me and Never Finished. These books were recommended to me by Isaac, who works at OpenBCI. He's a software engineer with our team, and I've been reading them for the past few months. And David Goggins, is a beast in the best way possible. He is considered by many people the toughest man on earth. He's a Navy SEAL, and he's completed multiple military trainings that no one else has done before altogether, in their life. He also has a world record in, I think, pull-ups, and he ran races like 240-mile race. So it's crazy. And what he does, you would not think is possible, especially given his upbringing. So he had a really rough upbringing. He was overweight. He was abused. He had learning difficulties. He didn't have money. Everything was against him. And he made the decision by himself to bet on himself and pursue these impossible dreams. And a lot of the people told him that he was crazy. I think initially when he went from overweight to the weight that he needed to get into the program, he was barely eating and he was exercising so much, and everyone was telling him that he was crazy, but he succeeded. And he wrote these books to teach you the mentality that he uses. And the reason why he likes, I think, endurance sports so much is because he makes an analogy of them to life. How you can keep pushing, even though you think, you've reached your limit, you can always keep pushing a little bit more, and you shouldn't listen to anyone else that's telling you that you can't do it, because a lot of the people that are telling you that that's crazy and you shouldn't do it haven't done it. So they don't have the experience. How can they know that it's not possible if they have never tried themselves, right? They're probably saying it because they feel guilty that they haven't done it. And so you humans have a tendency to try to pull down, even if it's with the best intentions ever to keep you safe, for example. I think it's an intrinsic action, that comes. And so he gives a few strategies, like, for example, recording your thoughts, your negative thoughts, and then listening to them and realizing if you are being, having like a victim mentality versus like a hero mentality where you're like, I can do this. And so I think his approach to life and the way that he tells it in the book is one of the things that is really resonating with me. The mentality of not listening to the people who don't have the experience, and the mentality of keeping your mind, like being your own advocate rather than being your enemy, and using all the negative energy, like transforming it into positive and just like thriving off of all the negativity that you have, turning it into, okay, now I'm going to show you that this is possible. So I think, the books are good. It's hard to summarize in one sentence, but that's the type of mentality and persistence that I think makes people achieve things that other people consider impossible. It's the persistence and the daily dedication and the belief in yourself that your limitations are just a perception.
Yeah, great advice. And I will definitely look into these books, especially because I do a lot in the space of coaching and self-coaching, where I write my own thoughts and, of course, look at them and question: is it the fact, or is it, just a story that I'm telling myself? So I think it's really in line with what I'm doing, and I think many people can benefit from this. So thank you so much for mentioning it. And because we're talking about neurotechnologies, I try to ask each of our guests, how do you see the field of neurotechnologies, let's say 20, 50, and maybe even 100 years from now?
That's exciting. I am excited for the future of the field. I think it has just started. The neuro revolution that Connor talks about a lot on his LinkedIn and on his talks, I think we're in the thick of it, and there's going to be exponential growth of this technology. And in fact, if you look at the number of neurons getting recorded like every year, it's growing similar to Moore's law. So the one that says that the number of transistors doubles every few years. And so I think neurotech is following a similar trend. And when I think of the industry, maybe in 10 years, there's two sides of it, non-invasive and invasive. I think on the non-invasive side, brain wave tracking and other, biosignals from the body that are currently not getting picked up by our, Apple Watches or Garmin Watch or whatever device that people wear. I think it's going to become part of the norm. So I think we're going to be able to build devices that are comfortable enough and, look fashionable enough for people to wear it in their daily life, and that we're going to be able to be drawing way more complex insights from the brain data, from your eye data, that's going to help you to adjust your routine for better health. That's the hope that I have from non-invasive, and I totally see it as a realistic scenario. I think one of the best entry points for this actually is sleep. So companies like Edun Technologies, they're building headphones to track sleep activity, and I think that's a great segue into what I'm talking about, because when you're sleeping, you can already test these devices and you don't need to wear it for the whole day. So I think this is one of the spaces where it's going to start happening, and then it's going to expand to our daily life when we're outside and at work, help us get to that flow state, improve concentration, etc. And then I'm also hopeful about the advances using non-invasive for diagnosis of conditions. So things like dementia, maybe tracking patients at home by combining sensors with VR or XR and having them, be in this environment maybe like a couple times a week and be able to test their performance at different tasks, or use it as sort of like a training playground for your brain, how we use like mobile apps, for example. I think that could maybe result in earlier diagnosis where you can detect subtle changes that you wouldn't be able to observe on yourself, especially if someone is living alone, for example. And then on the invasive side of things, I'm really hopeful as well, because even though I work in non-invasive, I do have a, big interest in invasive. I think they're both complementary. Right now, I mean, there's already people wearing these implants, BlackRock's implants, the BCI pioneers. They've been wearing them for years. And so I think that it's only going to keep getting better and be able to reach more people. And hopefully in a few years, if you have an accident or if you have a condition, it won't necessarily feel like you've lost all your abilities, but you'll have the option to maybe have this implant that's going to help you to do some of the things that you were, doing previously. So I think that's going to happen. And then that's obviously the first entry point, because the barrier for these people is lower. Like they're more willing to try a technology like this because they need it more than a person who hasn't had a problem. But I think once we get going with that, then regular people can potentially wear these implants like what Neuralink is doing, and we'll be able to control devices seamlessly with our thoughts or with other biometrics. I don't think that's crazy to think. I think it's going to happen. I don't know when, but I am excited, and I'm happy to be a part of it. So definitely within the next 50 years, I think that's, it's realistic to think that that'll be happening. 10 years probably non-invasive, and the implants for the people who have conditions. But who knows? Maybe in 10 years, healthy people have the implant too.
Yeah, absolutely. And also minimally invasive BCIs, device like stent road that is being developed. And one of our podcasts will be talking about that as well. So many opportunities, I think, so many opportunities for what you just described. So thank you for this. And if our listeners are interested to learn more about you, about the OpenBCI, maybe contact you, what is the best way to do it and where and how they can do it?
If you want to reach out to me, I think LinkedIn would be the best platform, probably. I'm pretty active on there. So I'll see your message. But I also have a website. It's evaesteban.com. So basically name and surname. And I do have, like, I post about my projects there. Honestly, I should probably update it because I haven't updated my projects in a while. But I have a contact form where you can message me and it gets to my email. And then, of course, if you're interested in what we're building at OpenBCI, then follow us. We have LinkedIn, Instagram, Twitter, YouTube. We have everything. So whatever platform is more convenient. And the website is openbci.com. If you want to reach anyone from the team, we also have contact details there.
Thank you so much. And we will add all that information to our podcast notes so that our listeners can find all this information. And before we wrap up, is there anything else you would like to tell or share with our listeners?
As a final note, I would probably share that you shouldn't be scared of reaching out to people. I think the neurotech space is still, small enough that a lot of people know each other. So whenever I go to events, I end up finding the same people, over and over again. And if you're someone that's looking to get started in this industry, I think you should reach out to some of the people that you admire in the industry, and there's a high chance that they'll get back to you, and then they'll be able to introduce you to other people in the space, and you'll learn a lot. So don't feel intimidated just because it's a new industry. I think that anyone that's listening to Neurocareers podcast, if they're not already in neurotech, do some outreach and try to interview people. I think that would be my first piece of advice.
Thank you so much for your advice, for being such a wonderful guest on our podcast and sharing your personal story and advice and all the information about neurotechnologies. I think it's so exciting. So thank you. I wish you all possible success in all your work and your personal advancements and also in your career. So I hope that we will be able to meet maybe on our podcast in 2 or 3 years and learn about all the developments that you have. So thank you so much.
Yeah, thank you so much for having me. I really enjoyed the conversation. And let me know if you're ever in Brooklyn and you want to visit the OpenBCI office. I'm happy to give you a Galea demo so that you can try it out yourself. But I really enjoyed it, and I appreciate your effort with the podcast. I think it would have helped me a lot back in the day to listen to a podcast like this. I was listening to some of your episodes earlier, and I found them very insightful. So I'm lucky to be a guest, and thank you.
Oh, thank you very much, Eva. Thank you.